Alright, here's a quick video showing a divisibility by 7 rule. I know there's a bunch of them out there. This is one that a colleague and I came up with and thought it was worth sharing. So what I did, I picked some crazy number, just picked a bunch of digits at random, here it is, and I multiplied it by 7. And if I didn't screw anything up right here, this is that product. And then what I did is I added 1 to this number and wrote it down here. So this number right here is not divisible by 7. It should have a remainder of 1 upon division by 7. So what I'm going to do is pretend I didn't know that, pretend I was just testing this number right here, and show how I could figure out that it's not divisible by 7. And really it's a 3-step process. None of these steps are all that bad, even for ridiculous numbers like this. So I guess it's a decent way of checking divisibility by 7. So here it goes. First step, I call it add blocks of 6. So essentially what you do is anytime you have a number that has more than 6 digits, take the first 6 digits, or I guess the last 6 digits, depending on how you think of first and last, and then the next 6, and then the next 6, and then the next 6. And add those up. So what I mean by that is, let's write that 215,399. That was this block of 6, and then my next block of 6 was 925,168. And then my next block of 6 was 123. 478, and then in my last block of 6 I just have this 4 4. You're going to write them over on this side. A way you can remember that you want to write them over there is because really you could think about this block of 6 as 0 0 0 0 4 4. So we got a bunch of zeros here. And now what I'm going to do is add up the columns. But to make my life a little bit easier, I don't really care what 9 plus 8 plus 8 plus 4 is. I just care what is the remainder upon divisibility by 7 of that sum. So you could add up 9 plus 8 plus 8 plus 4, and then divide it by 7. Well, let's see, let's do it. 8 and 8 is 16, and 4 more is 20, and 9 more gives me 29. And I guess 7 times 4 is 28, so the remainder here should just be 1. But there's an easier way to do that. Instead of adding them all up and then figuring out the remainder, you can figure out the remainder as you're going. So 9 has a remainder of 2. It's 2 more than 7. This has a remainder of 1, and this has a remainder of 1. So even though it says 9, 8, 8, I could think about it as 2, 1, 1. And 2 plus 1 plus 1 plus 4 is 8. And 8 has a remainder of 1 upon division by 7. Same logic for the next column. I get 2 here, I get 6 here, I get 0 here, and I get 4 here. So 2 plus 6 plus 4 is 12. And 12 has a remainder of 5 upon division by 7. And my next column, I got a 3, a 1, and a 4. 3 plus 1 plus 4 is 8, but 8 has a remainder of 1 upon division by 7. 5 plus 5 plus 3 is 13. 13 leaves 6 if dividing by 7 as a remainder. 1, 2, and 2 is 5. 2, 9, and 1. I guess I could think about that as 2, 2, and 1. 2, 2, and 1 is 5. So I get this 6-digit number. The first thing to note is that this ridiculous number here is divisible by 7 if and only if this 6-digit number here is divisible by 7. So what we can do just in step 1 is we can change any number into, in the worst case scenario, a 6-digit number. Unfortunately, there's no obvious way to tell whether 556,151 is divisible by 7. But we have another step that can figure that out. So step 2, which is what I call alternate subtracting blocks of 3, not the most succinct name, but essentially all it does is say, all right, you got a 6-digit number here. Is this block of 3 and this block of 3? So write it 5, 5, 6, 1, 5, 1, and then subtract. However, you want to subtract down. You want to either subtract down, or up, down, up. It doesn't matter which way you do it. You just have to make sure you alternate. So if you do this one down, you got to do this one up, and then this one down. So you can choose. It's totally up to you which way you do it. I'm going to choose to subtract down to avoid having negative numbers. So 5 minus 1 would give me a 4 down here. 5 minus 5, if I subtract up, this 5 minus this 5 gives me a 0. And then 6 minus 1 gives me a 5. But you could have also done 1 minus 5 gives you negative 4 up here. 5 minus 5 gives you 0 down here. And 1 minus 6 gives you negative 5 up here. Either way is totally fine. Either way, you're going to end up with one number by itself and then a pair of numbers on the other side. So either 1 up top and 2 on the bottom, or 2 up top and 1 on the bottom. And so these 3 numbers are what you're looking for out of step 2. We're done with step 2. That's it. Just get this little picture right here. Step 3. Step 3, which is what you do, is you take those 3 numbers from step 2 and you double, then add, then double, then add. So you always start with the number that's by itself. So I only have one number on top here, so I'm going to start with this 0. If you had done this differently, you might only have one number on the bottom, in which case you'd start with that. I'm going to start with this 0, and I'm going to double it. 0 times 2 is equal to 0. My first double right here is done. 0 times 2. You can kind of think about it as we're going to do this little path. So 0 doubled gives me 0. And the next step is to add. So I'm going to take that 0 that I got from doubling this 0 and add it to this 4. 0 plus 4 is equal to 4. Now I'm going to double again. I did the double, I did the add, now I'm on this double. Take this 4 right here and double it. 4 times 2 is 8. And then I've taken care of this double. My last step is to add. I got to add this 5. 8 plus 5 is 13. And because 13 is not divisible by 7, this original number is not divisible by 7. You might note that 13 has a remainder of 6 upon division by 7, whereas this crazy number was supposed to have a remainder of 1 upon division by 7. What happens is when you get the 6 as the remainder here, really it's a plus or minus 6. We lost track of the sign, whether it was negative or positive, by allowing the freedom of going in either direction here. Whatever. The point of the story is this method, step 1, step 2, step 3, won't tell you the remainder upon division by 7. It'll just tell you whether the number is or is not divisible by 7. Because 13 is not divisible, this crazy number is not divisible. Maybe that doesn't suit your purposes. Maybe you really wanted to know what the remainder is. Well, if you do, there's just a different step 2 you can do. So what I'm saying is still do step 1. Still come up with this 5, 5, 6, 1, 5, 1. But your new step 2 is going to be to make 3 groups of 2. So what I'm saying is 55, 61, and 51 will be my 3 groups of 2. And what I'm going to do for each of those groups is I'm going to triple the first number and then add it to the second number. So what I mean by that is 5 tripled is 15 plus 5 is 20. And I could write 20 down here, but since 20 has a remainder of 6 upon division by 7, I'm just going to write a 6. Similarly here, I got a 61. 6 tripled is 18. 18 plus 1, triple then add. 18 plus 1 is 19. I could write 19 right here, but I'm not going to. I'm just going to consider its remainder upon division by 7 to keep the numbers a little bit smaller. 19 has a remainder of 5 upon division by 7. Finally, 51. Triple this 5, you get 15. Add this 1, you get 16. 16 is what I could write down here, but I'm going to write the 2. Instead of coming up with 0, 4, and 5 using this method, you could come up with 6, 5, and 2 using this method from step 2. If you got 6, 5, and 2 as your answer to step 2, you could then go to step 3 where you double add, and say, all right, my 6, I want to double it. 6 times 2 equals 12. But really, instead of 12, to keep the numbers nice and easy to deal with, I'm just going to write 5 because 12 has a remainder of 5 upon division by 7. And I want to take that 5 and add it to this 5. Right, I already doubled. I doubled this 6. Now I want to add that product to this 5. 5 plus 5 equals 10. But again, if you want to keep the number small, you don't have to keep reducing these numbers. But I'm going to call that 3 instead of 10 because when you take 10 divided by 7, you're left with 3. What's next? Well, let's say I doubled and I added. I guess I should double again. Let's double 3 to get 6. And then take that 6 and add this last 2. You get 8. Note that 8 has a remainder of 1 upon division by 7, as does our original number that we were trying to check. So, using the original step 1, 2, 3, when we came up with this 13 right here, because 13 is not divisible by 7, we knew this number was not divisible by 7. If we needed more information, if we wanted to not only figure out whether a number was divisible by 7, but also figure out what the remainder is upon division by 7, we could do this as step 2 instead, this kind of grouping by 2. Or maybe you prefer this method instead, in which case you can do this step 2 instead of this step 2. This step 2 is called the Irv method because the guy who came up with it is named Irv. Either way, there's some computations for how you can figure out divisibility by 7 Rather than explain why this works, I think I'll do that in another video because I think it's a very different audience that wants to know why something works as opposed to how it works. So here's the how it works video on divisibility by 7. I add to the end of this video because when I rewatched it, I realized I left something out. Step 2 here. If you had done the step 2 differently, instead of subtracting down, up, down, you chose to subtract up, down, up, which is totally fine. You would have ended up with 2 numbers up here and 1 number up here. I didn't tell you what order you double add when you have the numbers in that configuration. What you would do, as I mentioned in the video, is you'll start with the number that's all by itself. So just like we started with this single number that is on top here, we would have started with the single number that's down on the bottom if we added in the other order. But what you do next is what I did not specify in the video. Next, you would add twice this number down here to the number on the left up top. So I guess what I'm saying is the order you do this is first start with the number all by itself, and then go to the leftmost of the 2 numbers that are together. So if you have 2 up top, step 2 is going to be dealing with the number on the left, and then finally the number on the right. So just like here, started with the 1 by itself, dealt with the number on the left, dealt with the number on the right. That's the same thing that you would do if you subtracted in a different order. Okay, now this is a little bit more complete, so I'll end this video for real.